Let's continue with example number 5. I'll set out and then we can pause and see if you guys can figure it out. Or we'll read it together. A theater staging a series of 8 different plays. So we have 8 different plays. You want to attend at most 3 plays. So the most that you want to attend is 3. How many different combinations of the plays can you attend? Now, what does this word at most mean? How many do we actually want to attend? At most, that means that the highest number that we want to attend are 3. So that means that we want to attend 3 or 2 of them or just 1. So you need to be able to set up 3 different combinations, and now because it's implied with an OR, we are going to add them. So go and pause if you can set up, and then we'll go through this. Got it? Great. So let's go and say, okay, how many different ways can I select 3 of those plays? How many plays are available? 8. How many do we want to select? 3. Or plus, how many different ways can I select 2 of them? 8, choose 2. Plus, or how many different ways can we select 1 of them? 8, choose 1. In this case, this will be expanded as 8 factorial over 8 minus 3 will be 5 factorial times 3 factorial. The next one will be 8 factorial, or it will be a plus in between, over 8 minus 2 will be 6 factorial multiplied by 2 factorial. And the last one will be 8 factorial on top. Denominator will be 8 minus 1 is 7 factorial multiplied by 1 factorial. Now let's go and expand each one. The first one will be 8 times 7 times 6 times 5 factorial, because I will cancel with this 5 factorial. And I still have my 3 factorial will be 3 times 2 times 1. Plus, the second one will be 8 times 7 times 6 factorial, because I will cancel the 6 factorial, and it will be 2 times 1. Plus, 8 factorial will be 8 times 7 factorial, because I will cancel with the 7 factorial, and I just have 1 factorial, which is 1. Now we can cancel the 5 factorials, cancel. 3 times 2 is 6. So for the first one, we have 8 times 7 is 56. There's 56 ways of selecting 3 plays. The 6 factorials cancel. And we can reduce this by 2. That'll give me 4, and that'll give me 1. So 4 times 7, there'll be 28 ways to select 2 of them. On the last one, we have 7 factorial, cancels. We just add 8 divided by 1 is just 8. You will always, by now, you should be able to get used to the fact when you say A, choose 1, that basically just comes out as 8. If you have 10, choose 1, it will be just 10. There's only, if you're selecting all of them, there's only one way. If selecting one of them, there's 8 different ways to be able to select one at a time. Now we're going to add all of these numbers, and we have 36, 92. So there are 92 different ways that we can select those objects. Now, let's continue with example number 6. The French club is composed of 10 boys and 15 girls. So we have a total of 25. The school is sending 6 club members to an all-paid trip to France. How many different ways can you select 3 boys and 3 girls? Now remember that we want to make sure that we select, even though we're selecting 6 of them, we want to make sure that we select 3 boys and 3 girls. So we're going to have to do it separately to assure that we have 3 of each. The keyword will be and. So go and set it up and see if you guys can come up with the answer. Go and pause it. Great. We have, how many different ways can we select 3 boys? How many boys are possible? 10. How many do we need to select? 3. And, so we're going to multiply. How many different ways can we select 3 girls? We have 12, 15, and we're selecting 3, so that'll be 10 factorial over 10 minus 3 will be 7 factorial multiplied by 3 factorial multiplied by 15 factorial for the second one over 15 minus 3 will be 12 factorial multiplied by 3 factorial. So let's go and expand the first one. It'll be 10 times 9 times 8 times 7 times 7 factorial. That will cancel with a 7 factorial. 3 factorial will be 3 times 2 times 1. So we're going to simplify this. That will cancel the 3. That will simplify to a 3. The 10 and the 2 will be simplified to a 5. So in this case, I have 5 times 3 times 8. That will be 120. Now, for the 15 factorial, will be 15 times 14 times 13 times 12 factorial. That will cancel with 12 factorial. And underneath, I still have my 3 factorial, which is 3 times 2 times 1. 12 factorial cancels. Let's reduce the 7. 14 and this 2 becomes a 7. So divide by 2, that's a 7. The 15 and the 3 will become a 5. So I'll just have 7 times 5 times 13, which is 455. So there's 455 ways that you can select 3 out of those 15 girls, 120 ways that you can select 3 out of those 10 boys. If we multiply together, that'll be 54600. 54,600 ways. Now let's work on the next process. Example number 7. David math test has 3 multiple choice. Let's see, 3 true and false questions and 5 multiple choice. Each multiple choice question has 4 different answers, A through D. How many different choices for answering the 8 questions are possible? So we have a total of 8 questions. So let's go and place, we're going to have to select the questions individual, the answers individually for each one of them. So 1, 2, 3, 4, 5, 6, 7, 8. The first one is true and false. The second one is true and false. And the third one is true and false. For the next question, we have 4 choices, A through D, A through D, A through D. 1, 2, 3, A through D, A through D. Now, we are selecting answers for each one. And we're going to do with the combination, same as the previous problems. How many answers are available for the first question? 2 of them. How many are we going to bubble in? 1. And because we are bubbling the first question and the second question, let's say you bubble true. Now, for the second question, how many answers are available? 2 of them. How many are we selecting? 1. For the next one will be 2 choose 1, that will be 2. How many answers are available for the fourth question? A, B, C, or D? There's 4. How many are we going to bubble in? Only 1. How many are we selecting? Only 1. 4 choose 1, 4 choose 1, 4 choose 1. And the last one, 4 choose 1. Now, 2 choose 1 is equal to 2. Same thing with this one. The next one is 4 times 4 times 4 times 4, and 1 more times 4. Many times you might see the answer as 2 to the 3rd power multiplied by 4 to the 5th power. And once you multiply together, you'll get 1,892 ways that you can select different answers. So that's why whenever you have multiple choices, the likelihood that you're going to get them all correct, if you guess, is going to be very small. And we're going to be dealing with the probability of getting them all correct on the next section. Now, example number 8. Let's go and read it together. You are going to set up a stereo by purchasing separate components. In your price range, you have 5 different receivers, 8 different compact displayers, and 12 different speaker systems. If you want one of each of these components, how many different stereo systems are possible? So very similar to the previous problem. We have, instead of 8 different questions, we have 3 different components. How many components are available for you? How many receivers are available to select from? 5. How many are you going to be selecting? Only 1. And you're also going to select the displayer, so it will be multiplication. How many different compact displayers are available for you to select from? 8. How many are we selecting? 1. And the last one will be speakers. And now at this point, 5 choose 1 should be 5, 8 choose 1 will be 8, and 12 choose 1 will be 12. So that gives me 40 multiplied by 12 will be 480 ways. There's 480 different ways that you can select. Now some of you guys might use the fundamental principle of counting, which is fine, but it's a little restrictive because on that principle, you must choose one of each. But if you use this method, it's a little more flexible to any type of problem. So this will conclude the lesson for today. Please email me if you have any questions, and thanks for watching the video. Have a great day.